21% of the air we breathe. We don't want too much. Here's why. Oxygen not only keeps you alive, but it also keeps this alive. Yes. What is this? Fire. Fire, okay? For fire to burn, we need three things. Fuel, heat, oxidizer. Oxygen all around us, okay? So, if I walk into a room that has no oxygen, not only can I not breathe, I won't get any fire. But do you think that means that if I have more oxygen, I can get a more dangerous fire? Yeah. If I add more oxygen, we get more fire. So if I walk into a room that has nothing but oxygen, and I decide to light a match, what do you think happens to poor me? Exactly. I burst into flames. I explode. Probably not good for me. So, we don't want too much oxygen. Which means there's other stuff in air, right? If oxygen only makes up 21% of air, we also have other gases. Like one that will make bubbles and balloons float. Do you know of a gas that will make balloons float? Helium, right? Helium is lighter than air. Now, helium is something that we have in our air. We also have this stuff, which is not helium, because helium is not something I can blow up on the stage. So there's another gas that is very flammable that's in our air too. We call it, anyone know? Do you know? So we definitely have carbon dioxide, but we don't have to worry about carbon dioxide exploding on us. Do you know? Hydrogen, yes. So helium, hydrogen, there we go. Carbon dioxide, we also have a gas called water vapor and argon, okay? So all these gases, for the rest of the show, forget those. Because they only make up a small bit of air. Oxygen is 21%. The other ones I mentioned are like 1%, which means there's one gas that makes up most of what we're breathing. Okay? One gas that makes up most of what we are breathing right now. Does anyone know what this main gas is? Do you know what it is? So oxygen is that 21%, right? Oxygen makes up a smaller bit of air. It's very important, but doesn't make up most of the air we're breathing. Do you know what it is? Nitrogen, yes, nitrogen gas, right? So, I focus on those ones at the start to show you how cool they are. When we get to nitrogen, we'll see that we have a gas that is not flammable, that is not toxic, because we're breathing it. It's not keeping us alive like oxygen, and we can't see it. So all these things make the main gas that we are breathing boring. Nitrogen is kind of boring, right? In its gas state, it's not as cool as these other ones, which sounds kind of sad for something that makes up most of the air around us. Well, it doesn't mean it's not important, especially if we change it into another state. This is the liquid air show. So now it's time to take the main thing in air and turn it into its liquid form. We're going to play with something called liquid nitrogen next. So if you've heard of liquid nitrogen, that's good. I'll call upon your past experiences with it to see what we already know. But if you've never heard of it, it's okay. I'll give you a quick introduction to what we have here on this stage. This thing has a special name. We call it Dewey. Yeah, that's the affectionate name we gave it because this thing is called a dewar, D-E-W-A-R. That is the special container that holds nitrogen. Anything that we use to hold nitrogen, we call a dewar. This thing is a glass. Insulated glass that is used for holding liquid nitrogen. What do you think we call it? Good job. Okay, cool. This is our glass dewar. So we're going to pour some liquid nitrogen into the glass dewar. Here we go. Okay. Here we go. Ah, nice. Look at all that steam or vapor coming off the top of it. Can you see it bubbling in there? Yes. Okay. When was the last time you saw a liquid bubble and steam like that? Yes, right? Have you seen the foam on the top, right? Wait a minute. Already I'm seeing two different things here. A volcano too? Oh, you did it in class where you had it bubbling? Yeah. put baking soda in to do that, right? Okay, so what we're seeing here are some very, very good, somewhat connected, but also very different things that all bubble, right? Hot water, right? A foamy drink, carbon dioxide, or sorry, baking soda giving us that carbonation there, right? I'm very confused here because I don't think that we want to drink hot beverages. But if you're boiling water, it's getting very hot. Who's heard of liquid nitrogen? Okay, let's make this even more confusing. What's the main thing you've heard about liquid nitrogen? It's cold. Okay, that confuses me even more. Because this looks like boiling water, and we've heard it's cold. But then we also see bubbles in cold liquids like soda and beer too, right? You know? So, maybe we need to try something, okay? We cannot prove this stuff is hot or cold by looking at it, which means we need to use another sense that we have to check temperature. Touch, feel, exactly. Thank you. Good. Thank you. Everyone here is very, very safe. If you see a pot of boiling water on the stove, putting your hand in it will tell you if it's hot, but it's not safe. So you should not do that. That is why we've invented tools to check temperature for us. And this tool that we can use to check temperature is called a thermometer. Exactly. So if we put this, it totally is a thermometer. You're correct. That is a balloon. Sorry, it gets a little dark back there. Hang on. All right, so if I take this thermometer and I put this thermometer into the liquid nitrogen, we will find out right away. Hold on. Okay, you're not going to believe this, but I don't have a thermometer. I just have balloons back here. I don't know. I asked for a thermometer, but they only gave me balloons. You know what, that's okay. I think we can do the science here with the balloon. Don't worry. You know, have you heard that story that, like, you know, Pringles, there was this myth that Pringles was supposed to be like a tennis ball company, but when the tubes showed up, or potatoes showed up instead, they just cut them up and put them into those tubes. So we're going to do the same sort of thing here. I don't have a thermometer and a whole bunch of balloons showed up, but I'm going to use these balloons instead to check the temperature. Here's how it's going to work. Balloons, what are they very good at doing? Popping. And also making animals, right? Like, here we go. Snake. It's a snake that got stuck, okay? I'm not a balloon artist, I'm sorry. Here we go. What we're going to do, though, is put this balloon into liquid nitrogen. A balloon is very good at popping. If you put a balloon into boiling water, there's a high chance it might melt the latex and explode. But if you put a balloon into the freezer, what do you think might happen to it? I mean, it could pop too. Honestly, the balloon does not seem to be a very good thermometer. So maybe we should just put the balloon in there anyway, see how it responds, and then maybe it will give us an idea of how it reacts. I do know that if I put a balloon into lukewarm water, like room temperature water, nothing's going to happen to it. So at least it will tell us that our nitrogen is not as hot or cold as we've heard. Okay? So here we go. We'll test it out. In 3, 2, 1. As predicted, nothing happens. Okay? So this still is not a very good thermometer because our balloon is not reactive. It's what? Oh no! Oh, it did pop. Okay, let's do another balloon. There we go, right? Because, hey, if you're doing a science experiment, you should do it again and again to see if you get the same results. So let's see. There we go. Second balloon, nothing happens. Okay. Maybe the last one will be okay. Yeah. Okay, well, you know what? This hasn't taught me anything, because we said if it's hot or cold, the balloons will pop. So that's weird. You know what? Maybe we should try something else. This is not a good experiment. I'm going to go to a better experiment. I'm going to boil some water, and when we boil that water, we'll compare it to... Whoa! Okay, hold on. Wow, that's amazing. I can't believe that. Look at that. We put 2 balloons into the liquid nitrogen, and those 2 balloons reinflated. It's amazing. I don't know. I only had 2 balloons. I don't know what you're talking about. All right, so, okay. Let's take a look at these balloons. We put them into the nitrogen and they deflated. I took them out and they started to reinflate. I have never popped a balloon and then watch it reinflate on its own. So I don't think we actually took any air out of these balloons, which means now we need to take a look at our states of matter again, okay? Solid, liquid, gas. All of this matter that we have around us, whether it's the air we are breathing, the gloves on my hands, the nitrogen that we're playing with, or you or me, all these things are made of tiny, 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 tiny little particles. Little small things that we call what? Atoms, yes. I cannot show you an atom here on stage. Well, let me find one. Here, ready? Oh, there's one. Here we go. All right, so between my fingers right here, I am holding 1 billion atoms. Yeah, here's the thing. They are so small that if I were to point at a tiny spot on my hand, I'm still pointing at billions of these atoms. I cannot show you a single atom without some very special, expensive microscopes. A picture? I can do one even better. Let's build a model instead. Here we go. This is even cheaper than a microscope. You can see a theme with my show. Okay. This, I spent all my money on nitrogen, okay? All right, so this thing is a Hoberman sphere. You might have played with one. It's a cool toy. But for this experiment, I want you to focus on these green things on the outside. We're going to say that these are atoms, and we need to give these atoms energy. Are you ready? Here we go. Okay, by giving them energy, do you think we're making them get hotter or colder? Hotter, yes. So we're heating them up. And when they get hotter, they move faster. And when they move faster, they start to spread apart.
Wow.
Yeah, this is a really, really big one. The biggest Hoberman sphere I could find, but I know they have some museums that have like giant ones in the ceiling. Anyway, this is helping us learn about our atoms. If those green things are the atoms, they spread apart when they get hot. But do you think they keep spreading when they cool down? No, instead, they're going to move slower. And when they get colder and they move slower, they start to move closer. And they move closer. My poor head is stuck in all of these atoms. You know what? This is actually kind of silly, but we can use this as an important teaching thing. Let's go back to our states of matter here, okay? Okay, so here's the thing. Liquid and solid. How do we turn liquid water into solid ice? We freeze it, which means when we get it colder, the atoms that make up that liquid water are going to slow down and come closer. And, well, let's imagine that I put my head into a bucket of water and it froze. Would it be easy for me to take that out? So let's heat up that water again. Atoms spread apart, flow a lot better, and now it's easier for me to move around them. So this is how we get to our different states of matter. You cool down a liquid that flows really easily, those atoms come closer, it's harder for them to move, and you've got your solids. Can we go back the other way? Can we turn a solid into a liquid? Yeah, heat it up so it melts and they flow better. Can we turn, like I said, water. Can we turn water into a gas now? Boil it, right? Or it evaporates. It turns into a gas, and those atoms spread apart all over the place. Much easier to move. Good.